In the first two lessons for today, we're going to be converting between radians and degrees when we're referring to the unit circle. So it's important to kind of understand what these two things mean. So I'm going to list all of the intercepts, my x-intercepts and my y-intercepts on the unit circle, first starting with degrees, because that's the one that most people are most familiar with. So if I'm starting here at the beginning, I'm going to be starting at 0 degrees. If I go from 0 degrees to a right angle, I know that this is going to be 90 degrees. Going another right angle from 0 and using a straight line all the way across, we know that straight lines from geometry are 180 degrees. Or we can think that we keep counting by 90s. From 0 to 90, add 90 more, takes us to 180. Add 90 more, 180 plus 90 takes us to 270 degrees. Add 90 more, 270 plus 90 takes us to 360 degrees, because one full rotation around the unit circle always is 360 degrees. It takes you back to where you started. So the second thing that we're going to refer to, we just talked about degrees in red. We're going to work with radians now, one that you might be a little bit less familiar with. Starting at the beginning again, you are still starting with 0 radians. Going from 0, every 90 degrees is equivalent to pi over 2. So 90 degrees is equivalent, converting to radians, to pi over 2. If I go another 90 degrees, I need to add on another pi over 2. If I am doing, let's do it to the side, pi over 2 plus pi over 2, I have 2 pi on the top, treating the pi like a variable, 2 on the bottom. 2 pi over 2, 2 divided by 2 is just 1. So 180 degrees converted to radians is pi. If I just keep on adding pi over 2, this was pi over 2, then 2 pi over 2, 270 takes me to 3 pi over 2. Counting another pi over 2, 3 pi over 2, plus another pi over 2, takes me to 4 pi over 2, which is equivalent to 2 pi. So we have now 5 different conversions from radians to degrees. We know that 90 degrees is pi over 2, 180 degrees is pi, 270 is 3 pi over 2, 0 degrees is 0, 360 degrees is 2 pi. But there's one that we're going to specifically use as the easiest one to convert back and forth between, and that's that 180 degrees is equivalent to pi. So for our first example, our first lesson today, we're going to be converting degrees to radians. When we're converting between degrees and radians, we're going to take our degrees and multiply it by pi over 180. So let's look at our first two examples. I'm starting with 270 degrees. I just told you that when we're doing degrees to radians, we're going to multiply it by pi over 180. Right now, since I am doing these two things being multiplied, I'm going to make them both into fractions just so it's easier for me to see. I have degrees on the top and bottom. We did this so that our degrees canceled out. Now on the top, I have 270 times pi, 270 pi. On the bottom, I have 1 times 180. So I have 180. It tells you that they want your answer in simplest form. So we need to reduce or simplify our fractions. The first thing that I see when I'm looking at 270 and 180 is that they both have a 0 on the end. So both of these pieces are divisible by 10. You can just chop that 0 right off, and now we have 27 pi over 18. Sometimes it only just takes one step to simplify. Sometimes it takes more than one step to simplify. So now I'm looking at 27 and 18. The first thing that I identify is that they're both divisible by 9. If you saw only divisible by 3 to start, that's fine. It might just take you an extra step. So 27 divided by 9 gives me 3 pi. 18 divided by 9 gives me 2. So converting from 270 degrees to radians gets me 3 pi over 2. We're going to do another example of taking 30 degrees and converting it to radians. So again, we're going to multiply it by pi over 180 degrees. My degrees cancel out. I now have 30 pi over 180. Again, the first thing that I notice is that they both end in 0, so I can divide them both by 10, and now I'm left with 3 pi over 18. See if we can simplify it again. 3 and 18 are both divisible by 3. So I get my final answer is pi over 6. Two more examples from degrees to radians. So I have 480 degrees. I need to multiply it by pi over 180. I notice I can cancel out the degrees. I also see they're both divisible by 10. So I'm going to write this as 48 pi over 18. When I look at this, I automatically notice that 48 and 18 are both divisible by 6. So in my numerator, the top 48 divided by 6, I am left with 8 pi. In my denominator, 18 divided by 6 leaves me with 3. Last degrees to radians example. I am going to start with 195 degrees. I need to multiply that by pi over 180. $195 is not divisible by 10, so I instead am going to write it out again as one big fraction. And since 195 ends in a 5, 180 ends in a 0, I know that they're both divisible by 5. I'm going to use my calculator to help me with this one, though. I'm going to do 195 divided by 5 in my decimals calculator. My numerator is 39 pi. And 180 divided by 5 is going to give me 36. My final step, 39 and 36, I can see are both divisible by 3. I'll get 13 pi over 12. The next 4 examples that we're doing is in the reverse order. We're doing radians to degrees. So instead of multiplying it by pi over 180, we're going to flip it upside down. We're going to multiply it by 180 over pi. So this first example, I was given 3 pi over 5. I need to multiply it by 180 over pi. You want the pi on the bottom when you're converting from radians to degrees. That way it cancels your pi out when you're given normal radians. So now on the top, I can do 3 times 180 to give me 540. And on the bottom, I just have 5 left over. So now I want to do 540 divided by 5. And I will get 108 degrees. Our next example is 25 pi over 12. I again want to multiply it by 180 over pi, going from radians to degrees. Again, my pi's on the top and bottom will cancel out. In my numerator, I have 25 times 180 to give myself 4,500. In the denominator, I have 12. So in my calculator, I'm going to do 4,500 divided by 12, and I get 375 degrees as my final answer. The last two examples are going to be examples when you don't have pi in your radians and you're converting it to degrees. So this first example we're going to do is we're going to take 5 radians and we're going to convert it to degrees. So I have 5 radians. If I want to convert it to degrees, I know that I need to multiply it by 180 over pi. But this time my pi's don't cancel out. There's not a pi on the top. So I'm going to start by simplifying my numerator. I'm going to do 5 times 180, which gives me, 900. And I need to divide it by pi. So in my Desmos calculator, I'm going to type in 900 divided by, and you can quickly either press the pi button or just type in pi. And Desmos tells me that it's 286.4788 going on. I want to round it to the nearest tenth. Nearest tenth means that you want to have only one decimal in your answer, and you need to make sure that it's rounded properly. So I'm trying to round it to one decimal. I'm going to look at what's to the right of that number. Since this 7 is greater than 5, that tells me that I want to round this 4 up. So I want to round it to 5. So I have 286.5 degrees as my final answer. Let's do one more like this. So I'm starting with negative 2.5 degrees. I need to multiply it by 180 over pi. I'm going to use my Desmos calculator to do negative 2.5 times 180. My calculator tells me that that gives me negative 450 in my numerator, pi in the denominator. I'm going to use Desmos negative 450 divided by pi. And Desmos tells me that it's negative 143.2394 going on. Again, I want to round to the nearest tenth, one decimal place that means. So I want to round this 0.2. Looking at what's next to the 0.2 is a 3. 3 is less than 5, so I can cut all of that off. And my final answer is negative 143.2 degrees.